This steel structure is nearly 3/4 the length of a football field, and it weighs 1,800 tons. Engineers had to lower it, gently, onto the seabed 300 meters below the Norwegian Sea, without cracking it, tipping it, or missing its mark by more than a few centimeters. Here's how they did it. It starts on land, at a fabrication yard in Egersund, Norway. Engineers build a template, essentially a giant steel skeleton, 74 meters long, 45 meters wide, and 26 meters tall. Its job is to serve as the foundation and protective frame for 2 gas compressors that will later be installed inside it, plus all the piping, valves, and structural supports around them. Every weld, every brace has to survive not just its own weight, but decades of ocean current, corrosion, and marine growth at the bottom of the sea. This isn't just construction, it's building an underwater factory. Once complete, the template is loaded onto a heavy transport barge. It's towed north, out into open water, toward the Åsgard field on the Halten Bank, roughly 200 kilometers off the coast, in an area where the North Sea gives way to the Norwegian Sea. The barge has to hold this cargo perfectly stable through open ocean swell, because the next step demands millimeter-level precision. At the installation site, a heavy-lift crane vessel pulls alongside the barge. Riggers connect enormous slings to lifting points engineered directly into the template's frame. Then the crane takes the full load, all 1,800 tons, and lifts it clear of the barge deck. This is one of the most critical moments in the entire operation. The structure now hangs freely over open water, and everything from here on is governed by weather windows, wave height, and vessel motion. As the structure enters the splash zone, it crosses from air into water, and this transition is deceptively violent. Waves slap against the steel, buoyancy forces shift suddenly as flooded members fill with seawater, and the crane wire has to absorb all of that motion without letting the load swing into the vessel's hull. Engineers plan this moment around calm weather windows, because a badly timed swell here can send shock loads through the entire rigging system. Once it's fully submerged, the ride actually gets calmer. In the mid-water column, wave action fades and the structure descends through relatively still water. But it's far from a simple drop. Remotely operated vehicles track its position and orientation in real time, while the crane operator winches it down at a controlled rate, adjusting for current drift so the template stays on course toward a target the size of a small parking space 300 meters down. As it nears the bottom, guide functions and piles help steer the template into its exact footprint, previously surveyed and prepared on the seabed. It touches down slowly, sinking slightly into the sediment until it's stable and level. Surveyors confirm its position and orientation are within tolerance, because everything that gets tied into this template afterward, pipelines, umbilicals, and eventually the compressors themselves, depends on it sitting exactly where it's meant to. This template became the foundation of the world's first full-scale subsea gas compression station, moving compressors that once sat on platforms down to the seafloor itself, closer to the wells, and unlocking hundreds of millions of barrels of oil equivalent that would otherwise have stayed trapped underground.